Record on this computer. Okay, so here we go again, guys. My name is Juan Saco. I'm the author of this tool, Exploit Pack, that is basically a framework for exploit development. Yeah, we do have like a few licenses that you can get on Exploit Pack, and one of those is the premium pack. And if you are a premium user, you can take advantage of the free trainings that we give every month or every 2 months to our premium users. We have decided also to make this kind of free trainings, but for everyone, not only for our premium users. So this is gonna be one of those. So you can also see how the trainings with Exploit Pack works. So because I like reverse engineering, I decided to make this training from 0 to pro, or from 0 to hero. Basically on this training, what you're gonna learn is how to unpack an UPX manually, how to do some tricks to to fool some tools that are used to automatically unpack UPX binaries. And my computer went to shut down. It's just asking for, yes, let's do it again. There you go. So, yep, okay, there you go. Okay, sorry, technical problems. Let me admit this guy. 1 second, there we go. Okay, so anyway, basically what we're gonna do now is to open a debugger. I like to use IDA, but you can use any debugger like Radare, GDB, OliDBG, Immunity debugger, but I do prefer using IDA. I think it's a really nice debugger, and also for the static and dynamic disassembly, it's really good in dynamic debugging. What I mean is, oh, people is still coming along for the training, so let me admit them. So let's confirm this. Can you still hear me, guys? This is working fine. Just type yes or unmute yourself. You can hear? Okay, great. So okay, let's begin. So there you go. So yeah, so UPX there. It's gonna be a lot to digest, guys. So I'm gonna be uploading this video to YouTube and also the training materials with the binaries that I have here. So you can also check it later on and do the exercises, follow along. So we do UPX there. This is the ultimate packer for executables. Well, basically what you can do with this is to unpack a binary, and then by doing that, you will create a stub inside the binary, and that binary we contain this stub, the segments will be changed, and then you will not be able to read whatever is inside the binary. So basically, if we put this inside IDA, like that, okay. So this is the original binary without any compression or anything inside. So you can see it. If I go to strings, you can see the strings there, and the program segmentation is correct. Yeah. So we have the text, e-data, air-data, and data segments, and also IDA detected by signatures all these functions. And besides that, it also detected that we have 2 subroutines and the start here. Yeah. And you can read it, you can decompile it, and it works perfectly, right? But if we close this and then we run UPX, oh, sorry, and then we run UPX with the like that, crackme original, and then -o, and then we say crackme upx.exe. Now what we have is the new crackme upx, yeah, .exe, a backup, just made a backup as well. UPX is I don't know if I said it before, but UPX is a open source project that you can get grab from GitHub as well. So we have the original and the UPX one, right? So basically, if we do exactly the same, we put it into IDA, and then we do OK. It says already. It says okay. I couldn't got the modules and couldn't import it from the import address table. That's the EIT, and then okay. So we couldn't find those, and then it's loading the binary and then strings, and there you go. There is nothing in strings and program segmentation. We have UPX 0 and UPX 1. Yeah. So that's it. So you cannot read the binary. You cannot follow it. So basically, this is the step, but we will find it later on. So basically, that's how it works. So the binary will be dumped. This one, the original, will be dumped inside another one that it will contain a stub. That is basically a function that goes through the encrypted code, yeah, or compressed code, and then it will, by using this function, what it's going to do is to uncompress it and then dump it again into another section, and then it will run it after is during runtime. It's going to change there, and then it's going to run it. Yeah. So this basically that's how packets work. Yeah. So what I'm going to show you is how to take this crackme.upx.exe that if we run it, oh sorry, not this one, you can see that it runs correctly, yeah, like that. This is the original one, it's the same, it also works, both works, but one is packed and the other one is unpacked. So I'm gonna show you a way to unpack it first using UPX, and then you do upx.exe and then -e, crackme UPX -o unpack.exe. Yeah. There you go. And now we have unpack it. And then if we put it again in IDA, boom, we got it back. Yeah. So as strings, and then we have it unpacked using UPX. There is a trick you can do to avoid this from happening, because that's not what you want. So unpack it, boom. No, we don't want the backup. So you can put the crackme UPX inside Unix editor. And then here, let's go for instance here, and then choose change a bit. It says UPX here, this one up there, and then 50, we changed 55 for 50, the hexadecimal value, and then we save it, boom. And then if we check here, it's, of course, it's already, it's still packet, you see? Still packet. But if we try it to unpack it again, running the same command, crackme upx.exe, UPX Manual, crackme UPX, and I should drop a file called unpack.exe, boom. Can unpack exception file is modified, taking care. So it couldn't detect there is a packet. So actually, if we put it on paid, it cannot detect, nothing found. So it cannot detect there is a, of course, the segments are still the same name, but it cannot be unpacked automatically using tools. So basically we change a byte, and then you cannot use like pExplorer or UPX itself to unpack this binary, even though this is using UPX. Okay, that's one trick, and that's a easy one and a cool one. So, okay, so because we modified, let's remove it and then pack it again, like that. So crackme original minus, no, we need to call X. Like that, -o, crackme upx.exe. There you go. Let's pack it again, and we have it here. So let's close it. And now let's start working on the crackme upx.exe that we know is packed. So we put it in IDA, and if we do like that, we cannot get anything, right? So there is another way of doing it. We have to do like this, like that, and now instead of just loading it with the default options, we have to do manual load, yeah, and remove create import segments. Because when you do a manual load, you don't want IDA to automatically create the import segments. So that's how it goes. So you have to enter manually the address of the binary. So we say, okay, first start on here. That is the like the base, and then load section. This one is, as IDA is asking, do you really want to do this? Load this section UPX at this address. Yes. Also this one UPX1. Yes, we want to. Also load this section, yes, and the header, yes, please, and segment start here, skipping the new one, okay, go ahead. And then we have it here, but remember that when we did it without the manual approach, we only got 2 sections, right? But now we have the header, UPX, UPX1, and resource. Okay, so now we have it here. Sorry guys, when you hear the bell, it's because someone is getting into the training. So let me accept those new guys. There you go. There you go. Okay. So now they are there. Okay. So back to the training. So now we have the header UPX 0, UPX 1, and resource. We can run this. We can run actually this binary, but actually, you know, guys, if you choose do this, and if I run it outside the debugger, if it run just fine, but I don't want to mix you up. But there is also a protection on this crackme itself, that basically if you run it inside the debugger, it's gonna check if there is a debugger present, and it's gonna it's gonna call an exit process. So it's gonna close the execution itself. Is gonna cancel it. And there are a few other protections from like anti-query, existing query, traps. There are a lot of protections. I'm gonna show you only this one. So we don't get involved that much into protections for binaries, but also I'm going to share you this reading material that you can look it up. This PDF, this is the ultimate anti-reversing reference. Yes, the ultimate anti-debugging reference, sorry. And here you can see everything about protections. One that I like to use is the trap flag. That basically the trap flag, every debugger is a trap flag. So when you run a binary inside a debugger, it will actually make a trap. And then like S-trace, like L-trace, radar, every debugger use it. So what some protections you can do is to choose call trap again and check if trap is already set there, and if it's set there, it's because it's inside of the debugger, and then you close the execution. The one that I was mentioning just before is this one. Then the one that we have here is debugger present. That's the one I'm going to show you inside IDA. But later on, first we need to unpack this binary. That is manually we're going to do it. So how do we do it? First, go to program implementation, go to UPX. This only works for UPX, but same concepts for others. So basically go here, we have here a D word, we press X, and then we can see that we have a sham near D word 40,000, yeah, and then we also have some references here, like here. Here we have two part of the here's, and we have one part that's here on UPX1 that is part of some execution code that we can go into. And if we see here, actually IDA already warns you about it. This says, this is a message that has been added by IDA itself. It says it may contain version source abuse and do harmful things. Well, and you've read it, I know you can read as well. So anyway, so we go here and we can see that basically this code, what it's gonna do is gonna go through where first it's gonna push A. Oh, actually, if you want some help, you can like I did, choose general auto comments, and then you can see also some comments for the opcos that we have here. So basically we have push A, mob AC offset D word blah, and then load specific address, and then every symbol is going to be moved from 6,000 hexadecimal into SE and loaded into 80. So what is that? Basically, if we check the binary here, we can see that the virtual size of it is 6,000, and it's already reserving that space. So basically what we can understand from here is that you don't have to be that smart to understand this, that this is the code. Yeah, it's reserving some space into that segment, and then what it's gonna do is to move everything from there, from here, for this size, and then it's gonna move it there, and then it's gonna do something here to actually uncompress that code, and it's gonna jump into it and run it. So here we can find the jump, yeah. Here, if we break X for cross-reference, and we can see that we have UPX1. There you go. And then here we can see that after that it's gonna do this jump here, and we can set up a breakpoint here. And if we run it, yeah, now it's running. It should hit my breakpoint. And then if we press F8, IDA is saying, IDA has detected that the external instruction pointer points to an address which is not defined as code. Would you like to directly create an instruction at AIP? And if we say yes, we're gonna jump to the OAP, that is the original entry point. Yeah, and as you can see now, we can actually read something. You see, Falcon 1 crackme. Yeah, because now the stub has been executed. Yeah, and now we are into the unpacked code of this crackme. So the UPX function, the stub that it was running, went into through all the compressed values, to all the compressed values that we have stored into the UPX1 segment, and then it dumped it into here, and now it's jumped there, and then it's executing it. Yeah, well, it's trying it because it's not breakpoint. Well, after my breakpoint, I jumped there. Well, but now what we could do, if we want to analyze this, we can choose to do a tech memory snapshot, and then say for the loaded segments, because if we do like open views and then segments, we can see that we have all these segments are on the L loader. Yeah, that basically, if you remember correctly, this says this is the header, UPX0, UPX1 resource. Yeah. So basically, if we do debugger, take memory snapshot for loader segments, and now we stop it. Yeah, we now have all these functions. What we need to do is to reanalyze the program. Yeah, and now we have this here. But as soon as so we have it here, right? Unpack it, that's what I mean. But on the UPX geo, right? But as soon as we run it again, the stub is gonna be run. The stub, the decompression mechanism from UPX is gonna run again, and it's gonna override this that we unpack it and took a memory snapshot. So again and again, it's going to happen. So it doesn't work. It's not. This is not enough. Taking a memory snapshot, it doesn't mean that you have the binary unpack it. Yeah. So how do we unpack it? So we go again there. We follow the jump. We get here into the original entry point. There is 40,000. Yeah, you see it here. And now what we have to do, we do Shift F2, so we can actually grab those segments and dump the memory into a new binary. So I brought this one. I'm also gonna share this one. So, but we need to modify from where to until. So again, we have to check here. We're gonna dump all the segments, these four. So from 4,000, that's correct, the start address, and then to the end of it. So it's like from here to here, from here for, yeah, 4,000 something to here. So it's a 40, A0000. So this is from, this is A 40A000, like that. And then what is this program gonna do? Is gonna, this is the output for IDA. Yeah, so I'm running this script that I wrote. So basically what it's gonna do is to choose, go from this address until this address, and it's gonna print every byte that it finds into a file. Yeah, that is gonna be called dumpmem.bin. Yeah, so run. There you go. Memory dump script by JSACL, save it as dumpmem.bin from this one to this one, and it's saved there. So if we close it, and if we go here, then we will see that we have our dump memory, yeah, file. And then we do like that. And then we can choose, do this and change it to exe. And then we have it here, the dump of the memory of the 4 segments. If we run it, it will not work because the segments are still not correctly aligned. So what we have to do, we can use a lot of tools. I like this one, editor. Put it here and then go to the sections and then dump fixer for every section. You see the values here, virtual site, virtual object, raw site, rather characteristics. And you see also the sections names there, and there you go. And now we got the icon of the program, right? But still not work. Still doesn't work because the import address table, yeah, so all the offsets for those for that table are wrong because they coming from the order from the UPX one, not from the original one. So what we have to do, we can use another program, this one, to fix. We could fix it manually, but it's a lot of work to fix those offsets. So basically what we could do is to get the original one, put it there, or the unpacked one that we got using the memory snapshot, and check for the correct offsets, but that will take a lot of time, and maybe not on a small crackme, but on a big program, it will take a lot of time. So what we have to do here is to, so you have to have running here again, the unpack version, go there, and then when you hit after the stub, when you hit the OAP, the original entry point, yeah, when you are here, then what we can do is to grab from that one, yeah, attached to an active process, we grab from there the import address table that process is using. So we do that, and then it found something. So it found the IT. It found it has been found there. Yeah. So now we could do get imports, and here we have the libraries with the correct offsets. Yeah, for the binary. Okay. One thing we need to change is the offset. Like that. So we will have the offset of the binary itself, and then fix them, and let's choose this one, the dumbman, and then it choose rebuild the EIT, and created this binary adding an extension does say I, and then if we go back there, and if we did it correctly, now the binary is unpacked again. Yeah, I hope you guys follow it along, but that's how manually you unpack a section binary. And then you can see that we still have the UPX data, UPX1, we have it here, but this is the one we are running now. Okay, if you go to strings, we can see that it's totally unpacked, and we can see the real code of the binary. Okay, guys, so now that we have the binary totally unpacked from UPX, we're gonna start with crackme this one. Let me check. So guys, don't do the questions on the don't do the question on the chat. If you have any question, just unmute yourself, yeah, and speak out loud. So let's start with this one. So basically, if we run it, the crackme that is already unpacked now, it will close right away. Yeah. So if you don't know where to start, something you can do, yeah, that I think I find it easy to do is we can just have it here. It's here. Sorry, close the like that. So this is the one. So when we say this, like username, password, we have to choose one, say bro, not me. Yeah, okay. So what we can do, something is like all these two strings, and then we can find one of the strings that is being used. And here we can see that the not me, yeah, we have some references there. we can see here that here's the where he's calling this this box. This we don't want to go there, so we say it's red, and there, like that. And then here's how we start. So if we go back there from those reference, so here, I think this is the beginning of the, so what I did, I went back like I was here. And then first I saw this one, and then went up, and then from the name of the subroutine, I press X, go reference, and then going back from the code, doing, this is the actual reversing, right? Going back. Then I set up a breakpoint, pressing F2 on the push IP, and then now if I run it, it just stopped it here. So I guess that's the main window. So what I can do is to change this one to main window. There you go. And now we change it as well here, right? Main window, and then you have the references. So basically from here, right now, I know that if I run it and hit the breakpoint and then continue the execution, yeah, go there, create window, and then it just crash it, right? If I decompile the code, I can see here that first is gonna do this, show the window, update the window, translate, and call dispatch. Something you can do is to go also to the here the imports, and here we can check the imports, and one of the imports is debugger present. So something we can do is to, well, there are two things. If you already found on the imports that is using this button progression, or maybe you will not find it because it's not a function like creating a trap or something, that's not something you will find here. But if you do here, if you double click on that one and then do cross reference, you can see where in the code is calling it is the debugger present, right? Like there, yeah. But okay, well, one way will be to actually put a breakpoint here and then jump like so. It's about present. If it's true, then it's gonna exit the process. Otherwise, it's gonna continue with the buttons that you see here. And then yeah, if build something, then it's gonna do not me wrong. Also, it's gonna check if this file is here, if the file contains this process address, and then if yeah, if it contains its function, and then it's gonna check for this memory and check for these sections, and then if that's correct, then it's gonna jump into congratulations, you have beaten my first multi-crackme. Couldn't find a function with the correct name, so that's the output of this. And then yeah, next time everything more than one character, and there you go. So I guess well, you have one or more ways to win this crackme. So another thing you can do if you don't know is to just set up breakpoints on every or the more general protections. So how you do that? First, you need to open this one, the modules view. Open modules window. Where is it? Oh, it's here. I used to have it here. Sorry. Okay, there, breakpoints, and then modules, and then we go to kernel 32, double click, and then look up for is debugger present, and then this is inside kernel 32, by the way, right? So double click on this one, and then we can set up a breakpoint into kernel debugger is debugger present, the function in kernel 32 DLL, right? So if our program ever jumps into this function, it will get a breakpoint there. So we can remove, we don't have to, we don't need to have a breakpoint into this debugger present inside the inside the binary, but we have it directly into the library inside this debugger present on current 32 DLL. So F9, and then continue. There you go. So we hit the breakpoint there, and if we continue F8, F8, and then it's going there. Now we are in kernel base DLL, return, and at some point it will return to our code, right? There you go. We can also do continue to return. There. Yeah, we are still there. So we can run until there, and now we are back into our code. So we can do like this, journal, function offsets, yeah, like that. And also can add this like that. Yeah, so we know exactly where we are. So we are here, and then after that, yeah, we press F8, and it's gonna do this exit code or that if sham is 0 or not. So what we could do is to just change the jump here to 1, and now if we continue execution, we get the crackme working here. So something we could do now that we found it, that we know where it is exactly. So this is inside. Our code is not on the it's not in there. It's on our code. So what we could do is to edit patch program, assemble, and then sham now is if zero, so we know that the debugger is present. We got now run it inside the debugger always, so we can change it to sham and set. So if not 0, and then we do like that, cancel, and then patch program, apply patches to file. Oh, yeah, create a backup. There you go. And now we have it patched. So we can go back there. If we say dispatch, now we can go into the breakpoint for kernel 32 DLL, and then we can remove it because we don't need it anymore. There. Now, if we continue the execution, it will always work because we already patched. So now we can continue. So here we can see that it's asking for a username and password. So let's not display this again. Like that, yeah. So we can go there. I think it's better if we choose press F5 and then we go like that into the compiled code, show window, update window, and then while it's gonna be there, trying to display it, and there you go. Yeah, and not me. So what we should do is I will take out that this breakpoint. We can disable like that instead of removing it, and then we can go to strings and try to find the not me, or let's try to go to the congratulations ID like that, references, fi, decompile, and then we have this one that is this is one of the message box that we wanted. There you go. The first thing will be, because it's closing right away, like that, not me. So after doing this, I think this is just for create windows like that. So this one we already fixed it. Then it's doing this while just creating the buttons, all those buttons. and then doing this, create window with the username. So here is creating the window, username static, password, and then setting focus to that window itself. And here, defining Windows process, destroy window, and I guess we can choose put a breakpoint like here. So the start, and here. Oh, sorry, there. It's comparing two operands there. I think it's this. It's hitting this breakpoint every time. So yeah, that's not the breakpoint we want. Let's remove that one. Actually, we can remove this one as well. So let's set a breakpoint here. If you, because you on IDA you can set up a breakpoint on the source code that you got, or you can set up breakpoint on the assembly. So what we need to do is to, maybe we can put a breakpoint here. Like that. There we can go there. Like that. There you go. There you go. Yes. So basically now it's doing congratulations here, like that. So what we have to check here, I guess. Yeah, so it's not taking every, it is not taking every one of these boxes. So it's taking one in particular, it seems. So its method is nothing. It's different. Creating the password, set focus. Okay, return if format is different. Okay, try that. Okay, so we can do this like that, setting a parameter. Yeah, every time I type something, it will break. Okay. How to get the source, the pseudocode? You need to speak up, guys. I'm not looking at the chat window. So pressing F5 on a function, of course. So here, what I guess, going back. Oh, actually, you know, I got lost because I only have this breakpoint here on source code. So there. So what you could do is to also use mark locations. So let's move this one so we don't have like a breakpoint just to get to know where we are. So if we go there and then do a 5, that I guess this one will be like the serial logic. So we can change the name of this one as well. So we can say so here we can say serial logic or something, right? Then like that. Yeah, and also change it. Now we have main window and serial logic. So something we could do is, because this seems to be the interesting part, that if we go here, here's we're creating. We can also move like that. Instead of moving like that, we can choose on the graph view. Yeah, there you go. Next time, enter one or more characters. So I guess we will get this message if we hit the correct box. with less characters than 0 or something. So now, yeah, there you go. That's the, I think it's the other way of getting it. So let's put a breakpoint like core procedure, create windows. No, not there. It's kind of hard with this monitor. So like there, and here, yeah. So let's look it up here. The param, so it's giving the free round, and the param should be, I think the param should be the name of the number of the box itself. So like that. Okay, so I think, and also here, if memory, okay, so in IDA, oh sorry, I shouldn't press that. In IDA, if we press R, it will show the ASCII values of those. You can press D to change it like that, but it doesn't contain anything, it seems. So yeah, I think we have to run it. So I think this is the parameter, yeah, R for char. So I think this is the number of the box. Let's try it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it must be this one. Okay, we got next time enter more than one character as the username and quitting. So now let's go there. Yeah, let's go here. Next time. And there. Next time enter more than one character as username. So this must be the username then. Yeah, I guess this is a username. It's checking if this is less than 2. So username maybe. Oh, I changed the name of this, so it should be this. Username maybe 2. Like that. I think this is exit process. What I changed, I don't know. I have to check out later. So okay, and here congratulations. So it's gonna jump to label 13. Okay, but it seems like there are more ways to jump there. So what we could do is to do like that, and then 1, then 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, and then press the correct one. And it just exited. Okay. He should have hit my breakpoint. Check why not. Oh, it should be here. Okay. We are not entering there, it seems. So let me wrong. One, 2, 2, 2, 3, 3, 3, 3, like that. So we are here now. We continue. Now it's gonna try to load this DLL, but I think couldn't find it. So we go here, sticking the strings, username maybe. I think this is a username length then. Yeah. Username len. There you go. Okay, if the username len is less than 2, so not 0 but 2, it's gonna ask you for a longer username. Now it's doing ws printf from the string 1 there. It contains 4, so it's a 4. And then, so this one is 4, and then we have lit. That's my username. Username input. Okay. So it's not there yet. So it's moving something there and making some string compare. So I think this is a. So how to add comments is like the backslash and then check for maybe serial. Let's say maybe serial. So it's checking if 4 is not this. It's gonna exit, and this is still not a, these two comparison, these bytes, they still have no values. So we continue. That. Username input. This is what we change it. And at one moment, it will call the compare. Like that. So I'm choose continued execution. Get window text A. So if we go there, if we press F5, it will jump into the pseudocode. So we can use this one. So now we're sticking this. Okay, it's doing get Windows text to just grab the values from the text box. And then I think it's gonna do the still doing the string compare, and then it's gonna call the first string compare. So it's 4 against 1111. So I guess we can say that the first serial is 4. So it's not 4. It's not 4, so it's quitting. Okay, fair enough. It wasn't 4. So let's do it again. 1, and the first one it is 4 now. There you go. or we can set a breakpoint there, but let's go one by one. I don't mind. So, I mean, we can choose set a breakpoint there and continue execution until we hit there. So let's go like this. Should be okay. So now we are back. So the get Windows text A, so we are here. You can see. Now it is 4. Yeah, 4 and 4. So we can replace that. This is a serial 1. Serial 1. And this is serial 1 input. Serial 1 input. Yes. 4, 4. So now we should do not exit. It should continue to the next one. And it worked. And it's gonna compare 2, 2, 2, 2, 2 against this serial. Okay, so this is a serial 2 input against serial 2. So let's do this. Open notepad, username Juan, serial 1 4, serial 2, serial 3. Let's go like that. And we can also here do R and press A to grab it more easily, like that. And then I guess this is the serial 2. And if we go back to the pseudocode, if we continue it, now because it's 2 to 2 is not the same value, so it's the string compare choose data false, so it's X string. So yeah, we can use the current ones now, at least the 2 that we have, like that. So username Juan, and the serial is 4 this and 3333 go. So let's put a breakpoint here. Boom. I choose continue execution so we don't go all over again. I know it's comparing 430 again my serial 3 input. So serial 3 input against serial 3. Let's do the same thing. So I'm double click on this one. It's showing me the values. We press R, yeah? So we get the ASCII values of it, and then A. Okay, now copy it, and I guess we have it like that. So I guess we have it here, the username, the first serial, the second serial, and the serial number 3. So I guess now we can run the crackme original outside IDA, and then we can do 1, 4, 5, 7, 4, 9, 10, and then 430, and then there you go, guys, and it's working. So I guess with this we can finish this training for reverse engineering from 0 to pro. Or so yeah, I'm gonna upload this video to YouTube, and also I will also put the materials that we use there, including the script for IDA, so you can do the manual UPX and to follow the exercise. And also I invite you guys to, of course, I will invite you to try exploit pack if you are into binary exploitation and exploit development. And if you like reverse engineering as well, this is the tool that you want to use from now on. And it's open source, it's multi-platform, it runs in Linux, OS X, and Windows. I mostly use it on Linux, sorry, just because I use Linux for my work. So, but yeah, it contains 38,000 exploits, more or less, and also all the 0 days that I develop, I put it in exploit pack. So as a premium user, you will have access to all my 0 days and the 0 days that I get access to. And those 0 days, they are also updated every month as soon as I have it. And of course, you can also use the exploit pack faster to discover your own 0 days. And as a framework, you can also use exploit pack to write those 0 days for yourself. And then you can use autobound. Yeah, it has this full packet of features for pen testing and red teaming exercise. So I really recommend you guys to try this out. If you like tools like Metasploit, Core Impact, or Immunity Canvas, this is a tool that you want to try next. Guys, thanks for taking this free training. If you enjoy it, please share it on your social networks so we can get the word out that this project in free trainings for everyone. So guys, thanks again for tuning in, and see you if there is a next one. See you on the next one. Okay, I'm gonna cut the video now. Stop it.